Binary molecular compounds. Okay, this is a descriptive name for a category of compounds. Binary, meaning two. Molecular, meaning that these are molecular in nature. They are not ionic. What was the characteristic of an ionic compound? What was the thing that alerted us to the fact that it was ionic? It has a metal in it, okay? These molecular compounds do not have metals. The binary ones are composed of exactly two nonmetals, okay? When we name these, we use numerical prefixes to indicate the number of atoms of each element present. There are no charges involved, and so we have to tell each other using prefixes how many of each. This is the group of compounds that students like the best because I think it really is the easiest. In general, we name the more metallic element first. Usually that's the element with the smallest group number. If they're in the same group, then you go with the greatest row number. This makes more sense when we look at the periodic table. Imagine the line, there's that diagonal line. If you're looking at, say, nitrogen and fluorine, which one is closer to the metal-nonmetal dividing line? Nitrogen. So the one that's closer to the metals in the periodic table is the one we name first. Okay. So here's the pattern for their names. A numerical prefix, the name of the first element unchanged, another numerical prefix, and then we take the main part of that element name and we change the ending to "-ide." Very much like what we did with the nonmetal ions. And of course there have to be a couple of exceptions. If there's only one atom of the first element, that prefix mono is normally left off. That applies to the first element only. This is an extension of chemists hating the number 1, right? Because mono means 1. So if we don't have to write it or say it, we're going to avoid that. So as an example here, NO2, there is one nitrogen, and so that's the first element. So we're not going to say mono. We're just going to say nitrogen, and 2 oxygens is dioxide. Okay? And we'll do some examples. This is important to note. These two compounds always use their common names. They do have systematic names, but nobody uses them. H2O is water, and H3 is ammonia. Those two you need to memorize if you don't know them already. You can freak your friends out by offering them a glass of dihydrogen monoxide. It's not toxic at all. Okay, so let's do a little practice here and name these compounds. So if we look at them quickly first, here, nitrogen, iodine, 2 nonmetals. Phosphorus, chlorine, 2 nonmetals. Phosphorus, sulfur, 2 nonmetals. Carbon and oxygen, 2 nonmetals. These are all binary molecular compounds, so we can use the prefixes. Students get carried away and they want to use the prefixes for everything, only when there's 2 nonmetals. So what's the name of this first one? Nitrogen. We're going to not use the mono because there's only one there on the first one. And the 3 iodines, triiodide, we change the ending of its name. Now, the double, that looks like an odd combination of vowels, doesn't it? 2 I's and an O together. It is what it is. What's the next one? Phosphorus, pentachloride. Yes? Oops.
For triiodide or other examples that would have 2 vowels put together, I'm pretty sure that master in chemistry likes for you to only use 1.
I think for mono, tetra, the rest of them that end in A, that is definitely the case, that when you get a double vowel, I think the tri is an exception where we do need to keep the I. I could be wrong on that. And you'll see them different ways in different places. And so this is one of those areas where not everybody agrees on. But I think the triiodide, we do keep the double I. That's a good question. How about the next one, P4S10? Tetraphosphorus, decasulfide. Decasulfide. That's a D. What about that last one? Carbon monoxide. And here's an example where we do drop, there's carbon. Gosh, I've got moo on the brain. If we just did it like that, that looks really weird, doesn't it? Monoxide? What is that? It's monooxide. But this is a case where we do drop that last vowel. So usually, not always, but usually when you have a prefix ending in a vowel and an element name beginning in a vowel, you usually drop the vowel on the prefix. Okay? And you may run into issues with mastering chemistry on that, and I'll just apologize for that. On an exam, which matters much, much more, I will not intentionally trick you. Okay, I would not give you, for this one, carbon monoxide and carbon monoxide as both choices, okay, and expect you to choose the better. That's just not very fair. Any questions? Let's see if there's another slide on this subject. Oh, yes. So we write names from formulas. We also have to learn how to write the formulas from the names. And again, these binary molecular compounds are fairly easy to do. So carbon tetrachloride, we need to know our element symbols. So what's this going to be? CCl4. Because the tetra refers to the chlorine. And it's a little unfortunate that in the name, the number comes before, in the formula comes after. And just deal with it. Dinitrogen monoxide. N2O. Okay. And there's an example where the ending vowel of the prefix was dropped. Carbon disulfide. CS2. How about selenium hexafluoride? SEF6. Any questions?